scientists have detected cosmic ray energy readings that could bring them closer to proving the existence of dark matter. Dark matter is a mysterious substance believed to comprise a quarter of our universe. Likely made up of unknown subatomic material, dark matter is invisible to telescopes and can be perceived only through its gravitational pull on other objects in the universe. Beijing's first astronomical satellite, that launched 2 years ago, detected 1.5 million cosmic ray electrons and protons, the study said, and unprecedented measurements found curiously low energy rays. Dark matter is said to make up roughly 25% of the universe.It. It does not reflect light, making it invisible. It cannot be seen directly with telescopes, but astronomers know it to be out there because of its gravitational effects on known matter. The European Space Agency says, shine a torch in a completely dark room, and you will see, only what the torch illuminates. That does not mean that the room around you does not exist. Similarly, we know dark matter exists, but have never observed it directly. Dark matter is thought to be the gravitational glue that holds the galaxies together, while just 5% of the universe consists of known materials such as atoms and subatomic particles. The team of researchers from China, Switzerland, and Italy, who published their first results in the journal Nature, said the data may cast light on the annihilation or decay of particle dark matter. This new unseen phenomenon can bring breakthroughs, Bai Chunli, president of the Chinese Academy of Sciences, said at a briefing. Dark matter is said to make up roughly 25% of the universe.It. It does not reflect light, making it invisible. It cannot be seen directly with telescopes, but astronomers know it to be out there because of its gravitational effects on known matter. After collecting more data, if we can identify it as dark matter for sure, then that is very significant, said Dr. Chunli. And if not, it is even more significant because they would be fresh new particles that no one had predicted before, Dr. Chunli added, to applause from fellow scientists. The Dark Matter Particle Explorer, DAMPE, is now collecting more data from space to help researchers figure out what it could be. Nicknamed the Monkey King, DAMPE was launched from the Jiuquan Satellite Launch Centre in the Gobi Desert in December 2015, after nearly 20 years in development. Its primary aim is to look for particles that make up cosmic rays, particularly electrons and positrons. Nicknamed Monkey King, the Chinese satellite was launched in the Gobi Desert in December 2015. The Dark Matter Particle Explorer's primary aim is to look for particles that make up cosmic rays, particularly electrons and positrons. Cosmic rays often come from exploding supernovae. However, if dark matter interacts with these rays, experts believe they sometimes annihilate each other, which produces electron-positron pairs. Normal atoms are made up of positively charged nuclei orbited by negatively charged electrons. However, antimatter is the other way around and has negative nuclei and positively charged electrons, known as positrons. In the first 530 days of observations, DAMPE detected 1.5 million cosmic ray electrons and positrons. When researchers plot the number of particles against their energy, they expected to see a smooth curve, writes Science Mag. Previous experiments have suggested there is a break in the curve, where there are more low-energy rays, which has now been confirmed by DAMPE. This could be evidence of dark matter. According to the current state of its instruments, DAMPE is expected to record a total of more than 10 billion cosmic ray events over its useful life of around 3 more years. Cosmic rays often come from exploding supernovae. However, if dark matter interacts with these rays, experts believe they sometimes annihilate each other, which produces electron-positron pairs. Normal atoms are made up of positively charged nuclei orbited by negatively charged electrons. However, antimatter is the other way around and has negative nuclei and positively charged electrons, known as positrons. In the first 530 days of observations, DAMPE detected 1.5 million cosmic ray electrons and positrons. When researchers plot the number of particles against their energy, they expected to see a smooth curve, writes Science Mag. The project is a collaboration of more than 100 scientists, students and technicians in China, Switzerland, and Italy, and funded by the state-backed Chinese Academy of Sciences. Beijing invests hundreds of billions of dollars in scientific research each year, under a 5-year plan for 2016 to 2020, that seeks to lift the country's technological research capabilities into the world's top 15. Dark energy is a phrase used by physicists to describe a mysterious something that is causing unusual things to happen in the universe. What we'd expect is that the expansion would get slower and slower as time goes by, because it has been nearly 14 billion years since the Big Bang.